All right, so now we're going to do an example, a KVL example. So let's say I've got my voltage source here. I got a resistor, another resistor, and then let's go with one more resistor here. And let's put ground right here. And I'm going to call this 1K, 2K, 3K, and 4K. And let's go with let's just go with a 10-volt source, okay? And we want to determine what is the current I that flows in this circuit. I'm drawing this as a loop. I know up to this point I've been sort of drawing it like such, where I draw it kind of like this, but you'll get used to some textbooks or other papers and different places that you'll see it, they'll just draw it like a loop like that, and it's the same thing. It basically means that the current is the same in all of these elements, which we already know. But I'm going to go ahead and just draw it like a loop, and I'm going to call it I. All right? I'll call it IX. How about that? I call it I all the time, so we'll just call it IX. Again, it's just a variable. So what I know is from my current, I can determine the direction that the current flows in each resistor. And based on that, I can determine where my plus minuses go across my resistors, and that'll tell me the polarity with which I write the voltage drop as I go around the loop. So again, let's just reiterate, just for review, the sum of all the voltage drops in the loop is equal to 0, which is what KVL basically tells us. So if we want to write the loop equation, just say the loop equation again, we can go ahead and start. You can start wherever you want. If you wanted to start here and go around, if you wanted to start here and go around, it would all work out the same as long as you do it correctly and stay consistent with the signs of the resistors, which again is dependent on the direction of the current. So let's go ahead and start. I always like to start with my battery because it just makes the most sense to me. So when I go across my battery, I know I go from 0 volts, I go across and I raise up by 10 volts. So I'm going to go ahead and write plus 10 volts. I am going up by 10 volts, okay? When I get to my first resistor, this one, I'm sitting here now and I'm going across the resistor and I'm going from plus to minus, which means I'm dropping voltage. So I'm going to write minus, and then that voltage drop is going to be equal to IX, my current, times the resistance of that resistor, which is 1K, okay? Now the second resistor, I get to this point. I'm going across this resistance. I'm dropping voltage. I'm going from plus to minus, and so I'm going to subtract, and that is going to be IX again, same current, multiplied by 2K, right? And so I keep going. I don't think I need to keep explaining this, so I'm going to just write it quickly. I have minus IX times 3K minus IX times 4K. Oops. Group those together. Minus IX times 4K, and this entire thing equals 0. Okay? All right, so from basic algebra, we can group the like terms. Let's just say that our goal in this circuit, maybe I already said it, but our goal is to find IX. What is the current IX? And then let's say that I'm also interested in finding this voltage, and we'll call it VX. Okay? So my problem is basically solve for IX and VX in the following circuit. I write my loop equation, and now I can very easily determine IX. I have everything given. All I have to do is 10 volts, and then I can say minus, and I can factor an IX out, and what I'm left with is a 1K, a 2K, a 3K, and a 4K, which those sum to be 10K, and this thing is equal to 0. I can say 10 volts is equal to IX times 10K by adding both sides, and now I can divide my 10 volts by 10K on both sides, and I get that IX is 1 milliamp. And we have solved for the current in this circuit using KVL. But now we got to solve for VX. Well, that's pretty trivial. I'm just going to basically be looking at this little part of the circuit where I have a 4K resistor. One side of the resistor is clearly at ground, so that's going to be 0 volts. The other side is at VX, which is what I'm interested in. I know that it's 4K, and I just determined my current to be 1 milliamp. So I can use Ohm's law. I can say that Vx minus 0, that's my voltage drop, is equal to I times R. My K and my milli cancel, and I get that Vx is equal to 4 volts. All right. So we found Vx and Ix in the circuit using KVL, and this problem would be done. And it would be just as trivial to go around the circuit and find the rest of the node voltages, Vy if I wanted to, Vz, and then we could call this like V0 if we want. And again, you would just go around and say, oh, well, I know Vx because I found that already. I know my current, I know my resistance, and I can find Vy using Ohm's law. Then I know Vy, so I can find Vz using Ohm's law. Then I know Vz, etc. And we should know right off the bat that this is going to be 10 volts just by looking at it, because we know this is 0. All right, so we're learning. Let's go ahead and move on. In the next video, I'm going to talk about Kirchhoff's current law, which is the other of the two very important circuits laws that we're going to be using all the time when we solve circuits from this point forward.